All right, good evening, neighbors. Thank you for joining. My name is Yoon Lee. I am the Director of Solar for Panasonic North America. I know there's been some interest in going solar in this community, and so the Sustainable Neighborhoods Program and the Sun Sustainability Committee have brought this webinar to you. The short blurb on the Sustainable Neighborhoods Program. The Sustainable Neighborhoods Program gives residents the opportunity to become active partners in making Stapleton a vibrant and sustainable community. Join us in organizing and participating in workshops, projects, and events that enhance the livability of our neighborhood. Not only will you help to reduce our collective environmental footprint, you'll also get to have fun with your neighbors. A couple housekeeping items. You're muted upon entry, so chat box is the best place to ask questions. This webinar is being recorded, so you can reference it in the future. And we have a 40-minute cap, so I'll try to keep the presentation to 30 minutes and save the last 10 minutes for Q&A. So here's the outline for today's webinar. We'll go through these one by one, but I'll cover benefits of going solar first, and then we'll do a quick technology overview. We'll talk about solar modules, inverters, racking, all the various components that go onto your roof. Also, we'll talk about evaluating your home for solar, just understanding how much solar you might be able to put on your roof and how much power you might be able to generate. And then we'll also cover getting contractors and bids once you're ready to go solar. And then finally, we'll cover the installation process. So as far as environmental benefits, there's plenty, obviously, but I'll list a couple here. The equivalent environmental benefit for a 5-kilowatt system on your roof over the course of 30 years, that's the same as about 3,000 trees being planted, 22 cars taken off the road, 0.6 rail cars of coal not burned, 41 tons of waste recycled, 1.6 tanker trucks of gasoline not burned. And also, just from a life cycle carbon emission standpoint, solar is 95% lower in carbon emissions than coal. And also, from a water consumption standpoint, solar uses 99% lower amounts of water than coal to generate the same amount of electricity. The other benefit I want to mention is if you're thinking about going electric for your vehicle, there are some benefits to charging from the grid, but you can see here it really depends on where you live. So some grids are dirtier than others. There's a lot more coal-fired generation in the Rocky Mountain area, and so if you were to buy an EV, it would be equivalent to a 46 mile per gallon car. And so, getting a solar PV system and pairing that with your EV is the best way to go. And then a couple numbers on just financial benefits. So for an average system size 5.6 kilowatt system in Denver, typically the cost for that is about $12,500 after incentives. It's about a 10-year payback, and over 25 years, you'll save about $25,000. That comes out to about $3.10 a watt to $3.30 a watt for a fully installed system. For technology overview, this is a typical PV system. You'll have solar panels on the roof, a mounting system. We'll cover all these, as well as an inverter. So for the modules themselves, there are 3 different types of modules. There's a thin film, monocrystalline, and polycrystalline. And the thin film modules are generally the cheapest, but they're also the lowest efficiency, kind of in the 13 to 15% range. The next step up, it would be the polycrystalline modules. Those are a little bit more expensive, but also a higher efficiency, kind of in the 15 to 18% range. And then finally, I would say the monocrystalline modules are the most expensive, but those generally have a much higher efficiency in the 18 to 20% range. Inverters, so you have to convert that electricity from DC, direct current, to AC, alternating current, in order for you to tie it back through your meter into the grid. And so there are several ways of doing that. As you work with installers, you may encounter several different options. And so the first option, and this is typical, you'll see what's called a string inverter. It's a central inverter that takes the power from all the modules and converts it to AC. And usually that's mounted kind of on the exterior of your house or inside your garage. The next option is it's called a microinverter. These microinverters, they are installed actually at the module, right behind the module, and there's one per module usually. Sometimes there's one for every 2 modules. There's some advantages to that. You're distributing your inverters, and so if one goes down, then you've got a whole bunch of others to keep on producing power. In the case of a string inverter, if that inverter goes down, you'll be without power. And then the final option is what's called a power optimizer. So this is kind of a hybrid. It uses a DC optimizer to manage the voltage and current, and then feeds that back to a central inverter. So it's kind of a hybrid of the two. So definitely a question to ask your installer as far as which type of inverter technology they are using. And then also wanted to talk about racking. So this is typically what you would see on your roof. If you were to install solar before the panels get put in, there are these standoffs that get installed. Those connect directly to the roof structure, and you'll see what's called a flashing that gets slid underneath the roofing materials to ensure a waterproof connection. And then there's some aluminum rails that typically span between each of the standoffs, and then the modules get installed on top of the aluminum rails. The other thing I'll mention is Critter Guard. So Critter Guard is this product that goes around the edge of your modules, around the edges of the array, and that's mainly there just to prevent, pigeons and squirrels and other critters from making a home underneath your PV system and chewing up all the cables. So definitely inquire about Critter Guard when you talk to your installer. All right, as far as evaluating your home, there's a couple things that you could do. You could, first thing I would suggest is go to Project Sunroof. It's a free Google product. You just go to this link here, and you can enter in your address, and Google will tell you, how much they think that you could produce using your roof. I've tried it. It's fairly accurate. I suggest you can try it as well. A couple other things about your home. You'll want to pay attention to roof orientation and tilt. The best case scenario is you have a south-facing roof, about 4 and 12 pitch, shade-free and obstacle-free. So you want a wide, expansive, southern-facing roof. That is your best bet for the most amount of electricity. As a rule of thumb, you could estimate about 1 square foot of roof space is equal to about 15 watts of solar power. So obviously you want to pay attention to shading and obstructions. Solar doesn't work if it's shaded. You can see in the picture there's this huge tree. That solar PV system, you may have paid a lot to install it, but it's not going to be generating a lot of electricity for you. And then finally, roof condition and age. I don't think you really need to worry about that if you built a home recently, but for some folks in southern Stapleton, if you're getting to a point where you need to replace your roof, I would recommend replacing it first and then installing solar on top of that, because the solar PV system is going to last 20 to 25 years, and so you don't want to have to remove the PV system in order to re-roof. All right, determining your energy use. So the next step I would do is look at your electrical bills from Excel and kind of plot out what your electricity usage is over the course of a year. And this is what the solar installer will use to kind of estimate how large a system you might need on your roof. And just one note about power versus energy. Power is measured in watts, energy is measured in watt hours or kilowatt hours. And so power is kind of instantaneous, energy is over time. And so as a rule of thumb, once again, you can estimate about 1,500 kilowatt hours per kilowatt of solar power as a rule of thumb for estimating your system size. So after going through all that, your first option for going solar would be to actually install it on your own house. So the way that works, solar gets installed on your roof. There's an inverter, as I mentioned, that's somewhere on your home. And then that energy is backfed through a bidirectional meter that the utility will install on your premises. And so over the course of the summer, if you generate more electricity than you use, the utility will account for that and kind of bank that. And then in the winter, when your solar PV system is not generating enough compared to your loads, the utility will essentially provide you those credits in the form of kilowatt hours. So this concept is called net metering. We have it here in Colorado with Excel. It's great. So this is one way to go solar. The other way, of course, if you've got a shaded roof or you've got a lot of obstructions or an old roof and you don't want to re-roof, you can still go solar. You can do what's called a community solar option. And so essentially what that is you own a piece of solar out in a field somewhere that a solar developer has installed. And the developer is able to take advantage of what's called virtual net metering. So they can allocate a certain percentage of that energy. The utility takes that into account and applies those credits to your electricity bill. And so you can still go solar even though your house might not be the best for it. If you do choose this option, I would encourage you to go to www.rooflesssolar.com and check out their website and enter in some info there. All right, so you're ready to go solar, and now it's time to find contractors and get some quotes. So a couple things that I would recommend. Get at least 3 quotes. This is a fairly large project that you're investing in. You want to make sure that that you're getting a fair price for the work. And so what are some things to look for in a contractor? I would say the first thing is to make sure that they're qualified. And so one way to do that is a NABCEP certification. NABCEP stands for North American Board of Certified Energy Practitioners. And it's essentially a professional license for installing solar. These practitioners need to take an exam similar to how engineers take a PE exam or how lawyers might take a bar exam. This is an exam for solar installers. And so you want to make sure that they do have a NABCEP certification. The other thing is, of course, you want to make sure they're licensed and bonded and insured. Just a note about that: insurance protects the company. Surety bonds protect the customer, so you want to make sure that the installer is both licensed and bonded and insured. Also, experience. How many years have they been in the business, and how many systems have they installed? You want to make sure they've got the right set of folks who are able to design and install the system for you and ensure a trouble-free operation for 20, 25 years. You can also check reputation on several websites: Yelp, Google, Facebook, or honestly, the best thing is ask for references. A lot of folks have gone solar, ask for references, and you can't go wrong there. And then the final thing I'll say is warranties. You'll want to pay attention to the workmanship warranty of the contractor. That's generally 1 to 2 years, but they should offer that, and that should include roof leaks from the installation of the solar. The other thing you want to check is equipment warranties. You want to make sure you've got at least a 10-year workmanship warranty on the modules and a 25-year performance warranty. And then for the inverters, generally it ranges from 5 to 10 years. Some also go up to 25 years. So obviously the longer, the better. All right, so you've contacted your 3 contractors that came out to your site, and now they've provided you quotes. And so how do you compare them? What are you looking for, and how do you make a good decision? So here's a example quote that I received for my home. Generally what they will provide is the preliminary design. So where the modules will be located, how many modules total, which roof planes will they be on. It should also tell you the system size. So that's the power, once again, overall power, kilowatts, DC. They'll also generally tell you the energy production, and that's how much energy they expect the system to produce. And that's in kilowatt hours per year. And generally over the course of 25 years, on a year-to-year basis, the system will degrade about 0.75%. And so over time, your energy production will decrease. But for that first year, it should match up with what they're anticipating. And then it should also talk about costs, obviously. Costs are measured on a dollar per watt basis. And the quote should also talk about what sort of incentives are available. And generally, that's going to be a 30% tax credit that you will get. And then I think the next slide, I'll actually talk a little bit more about that. And then finally, it should give you an equipment list as far as what modules, how many modules, what inverters they plan on using, and then it'll also talk about it should talk about any monitoring equipment that's installed as well. So as far as financial incentives, there's the federal solar investment tax credit, which I talked about. That's 30% credit. The other more state-specific incentives for Colorado, there's a sales tax exemption on anything you do with solar. There's also a property tax exemption. Generally, when you install a PV system, the value of your home increases, but you should not have to pay for that additional increase in property taxes. And then the last rebate that I'll talk about is the Excel Solar Rewards Program. And that's a cent per kilowatt hour incentive, and that's mainly to capture the RECs, which are the renewable energy credits that the utility uses in order to meet its renewable energy goals. And so currently that rec price is half a penny per kilowatt hour currently. And generally that'll be about $15 to $20 a month on good producing months, throughout the summer. All right, so now you're ready to purchase and you want to know what your options are. Generally, the installer will provide you kind of three different options. The first is what I would call just a straight up purchase. So you would pay out of your pocket for the solar PV system, and then over the course of time you will make that back because the solar PV is saving you money. So the chart here shows a 25-year return on your investment. And out of the three options, the solar purchase option is going to be your best bet as far as return on your investment. The next option I'll talk about is a solar loan. So you could work with the bank, or generally the contractor can offer one as well. But they can provide you a solar specific loan, or you can work with your bank through a home equity line of credit, and that would be a way for you to finance the install of your system. Generally, that return is a little bit lower, mainly because you're paying for interest over time. I will say one other thing about that is that sometimes the loan is structured such that the tax credit portion, the first 30%, is a separate loan that becomes due in 1 year. So it's really geared to take advantage of that tax credit, and then you take that money and you pay off that loan right away. And then the last option I'll talk about is a PPA. PPA is a power purchase agreement. You don't actually own the system on your roof. The solar installer or a third party actually owns the PV system, and you're essentially just paying for the energy that it generates over time, and that energy is generally lower than what you're currently paying. So you save money upfront right away, but the downside is, after the term is over, there's nothing to show for it. You don't have a PV system. So generally, it's great for saving money up front, but it usually doesn't make sense if you're thinking more long term. All right, so you've selected an option, you're ready to install. Here's just a quick overview of what to expect. So generally, there will be a site audit. There'll be a comprehensive engineering assessment. Folks may get up on your roof, take some measurements, look at obstacles and shading. Then they'll go back to the drawing board and actually draw out your layout in some detailed design, and do some structural analysis, put together the electrical single line diagram, and then they'll take those drawings to the permitting office, pull a permit. That usually takes, I'd say, 2 to 4 weeks. And then it's time to install once they've received the permit. The install of these systems generally shouldn't take all that long, especially if they have all the equipment, the modules and inverters. I've seen crews being able to install these systems in 1 or 2 days. So it should be fairly quick. The main challenge is just getting the permit and getting the crew availability so it works with your schedule. And then once the PV system is installed, there's a final inspection and commissioning process. We just walk through the system, test it, make sure it's working and functioning properly. After that happens, you call the utility. Utility comes out, does their check, and then installs the bidirectional meter. So this is the other part where you might be waiting for some time. Utility is generally not that quick to install these meters. I'd say it takes maybe 2 to 4 weeks once again. And then finally, monitoring and maintenance. That's something that you'll want to ensure over the course of time. You want to make sure your system is performing. So ask your installer about the monitoring package that they provide and whether you have access to see your system performing, and keep track of its performance over time. If there are any issues, you'll definitely want to call your installer to make sure that there isn't something wrong with your system. Let's see. All right, I think we're close to the end here. So yeah, for monitoring, once again, here's a sample screen that you might see. It includes the current power on the left, and includes energy over some portion of time. It could be for the day or for the week or for the month. It should also give you some indicator of carbon emissions avoided. And then generally some of the more sophisticated monitoring systems there are some drill downs. You can do some custom analysis and look at your system in some more detail. But this is a good way. I would suggest checking it at least once a month to make sure that it's operating. And some installers will actually send you an automated report, which is nice. And I think that is the last slide. So if there are any questions, feel free to ask them now. All right. Well, no questions. Thank you very much for attending the webinar. This will be uploaded and shared for future reference. Definitely appreciate it. And looking forward to seeing you go solar soon. Thanks all.